Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but a lot of the same principles apply over in the UK as well. Now, if you have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring that. And if you're watching this after the premiere, then just feel free to leave a comment underneath the video, and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on Diagnostics technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on, so I had a group of about 30 different franchisees I worked with, as well as the shops that they service, in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru, so I worked in a dealership, and over time, I guess, I just became that default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that had come into my bay. Then before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So let's get into vehicle maintenance functions. That's our topic for this week. And I'm talking about not just changing your oil, rotating the tires, more along the lines of here's the things we need to use the scan tool for in the changing of the oil and rotating of the tires and things like that. So many, if not the vast majority of vehicles nowadays anyways, need a scan tool to do even the simplest things. Oil reminder resets, parking brake, putting it in the service mode so I can change the pads, battery reset, and it's just a 12-volt battery too, not even EV or hybrid batteries. I'm just talking a regular 12-volt battery. You need to reset the system as well. TPMS reset for our tire rotations and any other tire work we might be doing. And on diesels, the DPF regen, right? So we might have to get that soot out by burning it and making more soot. Anyways, so we're going to talk about for the next 20, 30 minutes or so. And first up is going to be oil change functions. So it is important nowadays as well to make sure that you have an accurate, current access to information because things can change on a whim on the fly. So here's an example. I got a 2013 Chevy pickup on the left and a 2014 Chevy pickup on the right. Both have the same size engine in there. The 2013 takes 5W30 oil and 6 quarts of oil. And the 2014 takes 0W20 oil and 8.5 quarts of oil. So just 1 year change, if you weren't paying attention, if you didn't have current information on it, you might say, oh, well, it takes 6 quarts because 5.3 is always taking 6 quarts. So I'm just going to put 6 quarts in it. However, also on that 2014, it actually takes 8 quarts. It doesn't take 8.5 quarts like it left the factory. It takes 8 quarts because they revised it down in a bulletin right there, this PIP 5231A. So there was a bulletin. They said, hey, used to take 8.5 quarts. Now we decided it needs to take 8 quarts. So here's what we need to do. So you can see in here, this is in our quick lookups feature, right? So this is the 2013. And you got the 5.3, takes 6 quarts of oil, and it's 5W30. You go to the 2014, the 4.3 still takes 6 quarts of 530, but the 5.3 takes 8 quarts of 0W20. And notice how it says down here, the engine oil capacity has been updated from 8.5 quarts to 8 quarts in reference to GM's document this. So having current information at your fingertips is very important as well. Not just, can't get by with that book hanging on the oil rack anymore, right? You gotta actually double check, especially when in doubt. Maybe even when not in doubt. Also, once we're done changing the oil with the proper amount and the proper viscosity, we may need to reset an oil light. So in this case, we have a reset procedure you can do through the driver information display. That'll list it. Or there is also built in to the scan tool, there may be a service interval reset as well. So in this one on the GM, it's going to set the value automatically to 100%, and you can scroll it down in 2% increments if you want to do something other than 100%, which don't know why you might need to do it. Oh, I forgot to do it and when it was here 1,000 miles ago. So now I'll just bring it down like 25% or whatever, right? Whatever that value has to be. You can do it if you would like. So there's what the screen would look like. It's just going to tell you what the current oil life remaining is. And then you can just lower it down or raise it back up if you need to. Simple as that. Now let's talk tires. So TPMS reminders, resets, relearns, what have you, vary across manufacturers, and even on the same manufacturer could have multiple different ways on how to do it. So in this case, this is on a 2018 Acadia, and this is got at least 11 different procedures on how to do the TPMS on this. So set the tire pressure, set the parking brake, etc., etc. It tells you a bunch of different things you need to do. Then you need to use an activation tool, which we're going to talk about here in a second, to go around the tires and make the horn beep, basically. 2018 BMW 330 done all through the iDrive system, which is kind of like their driver console thing. So my vehicle status, reset tire pressure monitor, start the engine, perform reset, and then drive. And then they'll keep going until they detect where each tire is. So you don't have to use a tool for that. After driving faster than 19 miles an hour for a short period, the set tire inflation pressures are accepted as reference values. Reset is completed automatically while driving. Pretty helpful. And then there's this 2018 Ram 1500 right here. So that says there's no reset procedure available for it. But if we go into our functional reset, which is another portion using the scan tool there, is behind security, of course. It is a 2018 Ram. And then we have where you have to manually enter in the ID numbers. So they have 8-digit ID codes. So this function should be used to write the left front tire sensor ID is the one I picked. It'll tell you what the current ID is. You'll hit continue. Make sure you have all 8 characters of the sensor you need to program available. It can be found on the tire sensor label itself. You'd hit edit. And then you punch in the number and hit OK. It's going to double check and confirm that this is what you want. You hit continue. And then tire sensor ID programming successful in this case. On Nissans, for the longest time, they used to have 2 ways of doing it. That's it. One way with the special tool and one without the special tool. So if we go in under functional reset, we have registration tool with the J tool. It's a J45295 if you care, but that's what they call the TPMS activation tool. Many varieties out there, with the tool or without the tool. So if you go with the tool, you'd need, of course, your activation tool. So this is TPMS 5, this is TPMS 6, TPMS 4 would work, TPMS 3. Any of our TPMS activation tools would work because they have antenna on there and a little button you press, and that activates the sensor there. So you would need a separate tool of some sort to go around the different wheels. So, and then we also have without the tool. So it only works with if you have existing sensors, like you rotated the tires or something. It does not work if there's a brand new sensor install. You have to use the tool, the triggering tool. So in this case, without the special tool, we will set the left front to 34, right front to 31, etc., etc. And then you'll drive the vehicle down the road once you're all set. So key on, engine off, select continue, TPMS light in the dash will start flashing. Drive the vehicle 5 to 15 minutes until test completed is displayed. Vehicle must be driven. TPMS light will then go out. Fails to complete, exit the test and attempt to test again. Follow the instructions in detail. Basically, you'll drive it down the road. It's in learn mode, and then when it sees 35 psi coming out of a tire, then it knows that's the left front tire. 31 psi, well, I know that's the right front, and so on. So that's an interesting way to do it, but that's how they've done it for many, many years. How about a battery? Many manufacturers now have battery management systems, like I said, not just for EVs or hybrids, but for a regular 12-volt battery on there. Battery management system uses sensors, controllers, and software to monitor the battery state of charge, and that allows the vehicle to charge the battery depending on load and state of health. So it can increase the capacity or increase the voltage and the current flow to acclimate to the battery, and it adjusts over time and it learns. So when a battery is replaced, the system needs to be reset, usually with a scan tool in order. So in this case, I'm on a 2016 Audi S5. There is a coding and configuration function menu, and you can read the code, go into the configurations, and then program a new code. So write down the current code before you program a new one. Allows you to re-enter it later if you need to. So you hit continue. There's the code, and you hit edit, you type it in, and then you hit program. Simple enough. There was also a parameterization menu in there when the battery is replaced. So you can go in and it will change. You can change the capacity of the battery, serial number, etc. in there. You type them in, hit program, you're done. There's multiple other different ways to do it on multiple different other vehicles, but this is just one that I decided to pick here. We'll see another one here in a few minutes when we go live on the tool. Brake functions. So this has been very common in the last 5 years, at least 5-10 years. So we need to retract the parking brake in order to, because they're on the calipers. So in this case where they got electronic calipers, you need to retract the parking brake. And most vehicles have electric parking brakes now. So service resets and relearns is another place we can go in there. That's in the many of our tools has that quick learn menu. And in this case, first thing on top is going to be any maintenance functions, and we see replace disc brake pads. It's a 2015 Kia Optima, by the way. So yeah, it's a 10-year-old car. So yeah, it's been at least 10 years. Functional resets and calibrations. It'll give you some other repair information up there, a link to ShopKey if you have ShopKey. And then we come down here. It's going to give you not just the resets, relearns that need to be done. It's also going to give you any bidirectional controls that might be related to that as well. So just releasing the actuator itself, applying the actuator, maintenance mode for the parking brake, engage and disengage, pad mode before and after change. So if we want to change our pads, we would go into before change. Before changing brake pad, this function should be performed. This will allow you to push the piston into the caliper by retracting spindle nut with actuators. So it's an electric nut, or basically an electric spindle there that holds the piston tightly. Some vehicles it will retract the piston itself. Some vehicles it just retracts the thing that pushes on the piston. Then you still have to physically push the piston in as well. So don't just. I have gotten a few phone calls on that. This just crossed my mind. I have gotten some phone calls on that before. It's like, oh, well, it didn't retract the piston. Okay, not every car retracts the piston. Sometimes you do still have to, do the grip trick. We used to use a big old pair of channel locks, right? Or you can use the other specialty tools that are made for it as well. So you do before pad change mode, and then change the pads themselves, and then execute pad change mode after pad change. While pad change mode is in progress, you will get a DTC, and a test message will be displayed in the cluster. We hit continue. Engine off, ignition on, correctly operating modules, release the parking brake, brake pedal, and parking brake switch while the ignition is on. So don't touch anything dealing with the brakes. Then you go into continue. You change your pads. Once you're done with that, you go to after change. Engages the electronic parking brake after the brake pads have been replaced. Warning, do not use this function while the brake pads are being replaced. Might blow a piston out or hurt a finger or something like that. Please be sure to take general safety precautions before activating this function. So make sure that everything's assembled, basically. So you hit continue. And then it's going to go and it's going to compress the parking brake again. Keep stepping on the brake until the motor stops and the whole process is finished. That way it knows where closed is, right? You hit OK. And there you go. Easy enough. Now, diesel functions. Not a lot of maintenance specific for this. But we do have to think about the soot after treatment system. So things like the diesel particulate filter right there. Our exhaust temp sensors might need a relearn. Back pressure sensor might need a relearn. But really the only maintenance item I would think on this list would be the DPF. And it's not going to be all that common, I don't think, to have to do a regen, because theoretically it's supposed to do it kind of on its own, but doesn't always. So diesel particulate filters, their job is to catch the soot, store the soot, burn the soot. Catch the soot, store the soot, burn the soot. So it does this by going through a honeycomb thing. Forget what I'd want to call it. Substrate, I guess. Honeycomb substrate, where the exhaust is going to go through the open holes, and it's going to be blocked by the closed holes, because the closed holes, whereas the soot gets collected in here, and then it goes out the closed holes out back. So we wouldn't want to be clogging those up. We need to get them a pathway out. So they go up and down, and all the soot gets collected inside these things. However, if it's not regened, or it goes way too long until a regen, you could have clogging like this. So it's fully clogged. That is not regenable. It's not going to allow you to do it. Most vehicles will calculate a soot load and then figure out, oh, I can or cannot do it. Sometimes vehicles will display a code that says, ash load is too high or something of that nature, with soot load is too high, and regenning is at that point impossible. So there are different ways of doing a regen. A passive regen is going to be when the DPF temps are high enough to burn the soot off themselves without needing to add anything extra. Only happens under high load situations. So think towing a boat up a mountain probably would be when that would happen. Active regen can be initiated by the PCM or by a scan tool. Can be while driving or while stationary. Extra fuel, diesel fuel, is added to the exhaust to raise DPF temps to approximately 1,025 degrees Fahrenheit. So pretty darn hot. And then there's a parked regen, which can be initiated by a dashboard switch or also a scan tool on some vehicles. Used when attempts at active regens fail. So let's go live on the tool. Take a look at a few different things. Pop that open there. Pop this open here. Just want to see. All right. Okay. So, let's go through a few different vehicles. So, vehicle history. 2016 Focus. So if you were here at the very, very, very beginning and you watched the video at the beginning, I walked through this in more detail than I'm going to right now. But on a Ford Focus, this 2016 edition Ford Focus has windshield wipers that go like this. Not like this, right? So they go the crisscross ones. No linkage at all. So they're individual, like stepper motors, basically. Individual motors, and when you do any work on the arms, you need to recalibrate it. So that's in the body control module under functional tests, and then you will see the wiper motor module calibration. So it places the wiper motor module in calibration mode. Perform this procedure if the wiper arms have been removed and installed. Before performing this procedure, please make sure the following operations are complete. Make sure the wipers are on and installed correctly. Battery sufficient charge. Low battery voltage may prevent this from happening, and the windshield needs to be clean and dry. Make sure the ignition is on, engine not running, and then it puts it in calibration mode and basically pops them up. Then what you need to do is you need to set the they'll go to a pre-initialization position. You then need to gently pull the wiper out, the whole arm out towards the A-pillar, and make sure it's within 50 millimeters, or the gap is 50 millimeters between the edge of the windshield and the wiper. And then once that's done on both of them, press the wiper washer switch down one time after pressing it 3 times to put it in that mode. Sets the current windshield wiper arm position as approved position, and they will go back to park. So you can actually see how that looks in the video. It's kind of neat. And then wiper motor module goes back to normal mode when you're done. Carry out a low-speed wiper test, and then a high-speed wiper test to make sure everything works. You'll also notice this has 2 TPMS training modes as well, with and without scanner. So it's one without scanner. So it's going to tell us to press and release the brake pedal, do a couple tap dances, I guess. Also has a battery monitor system in this Ford. So it does a couple things. So it does the battery monitor. This reset needs to be done when the battery is replaced, body control module is replaced, or when instructed by a workshop manual. So anytime the battery is replaced, because once again, it'll change the alternator output based on the battery health. And then, of course, it's not going to let me do it because I'm in simulator mode. The other thing that this will do too, this reset, is if the vehicle is sitting for a while with the key on and the battery level gets too low, it'll start shutting modules down until you reset it. So that's another function that can be done on that. Let's just look here under oftentimes too, we also have service interval reset, service maintenance reset on the main menu of the vehicle. So this one says put it in run, simultaneously apply the alternator and brake pedals and hold the fully applied position. After 3 seconds, oil service in progress. Goes through, disappears after 25 seconds, and service oil reset complete displayed. So mash down the brake, mash down the gas, and you'll do that. Don't need a scan tool for it. So if we don't have a scan tool procedure, usually we will tell you how to do it without a scan tool, on the scan tool. All right, next one's is BMW here. And on this one, I wanted to go on the engine and look at some functional tests in here, special functions. So we have a battery replacement in there as well. All right, register a new battery. It's going to go through. Battery replacement is programmed. The next step cannot be canceled after starting. And it resets it. Basically resets it back to 0. Reset adaptations might need to be done certain times. Evaluate battery state of battery charge could be helpful. Engine adaptation values after you do a tune-up. Cooling system ventilation after I fill the cooling system. Let's see. So cooling system venting. Perform the following steps in the specified order to start the bleeding procedure for the engine cooling system. Bleeding procedure takes about 12 minutes. Therefore, make sure you have a charger connected because it's going to run it up and down a bit. Switch on the ignition. Switch on low beam headlight, which prevents the vehicle from going to sleep. Both temperature selectors at maximum. Press auto button for air conditioning. Blower output to minimum. Fully depress the accelerator pedal for 10 seconds. Do not start the engine, and then bleeding of the control system will activate automatically after this. So I can't do it in sim mode, but that's as far as I can go. But, a lot of vehicles nowadays, the cooling system's set up where you have to vacuum fill it too and bleed it. So you might have to do both. And there we go. It would go through and it'll tell you the pump speed, etc. So I'm just going to cancel it. So, because we can't do anything with it anyways. Right? Valvetronic and Vanos, that's kind of sort of related. I mean, it's oil operated, a lot of it. So somewhat related to maintenance, not really. And this one probably has brake pad change mode too. Yeah, replace brake pads right there. And then we have revert mistaken brake pad reset. So I accidentally redo my wheel alignment. There's another one. It needs to be done quite often nowadays. All right, next one I want to do a diesel to show a regen. F350, one of the more popular diesels over here anyways. Don't have too many diesel cars over here, so it's kind of hard to show a regen on a diesel car. But it's going to be a similar process. So if I go into functional tests, special functions, on this truck it has a dynamic regen and a static regen. So I can either do it while driving down the road, or I can do it sitting in the parking lot away from flammable stuff. Procedural command to DPF regen. A manual DPF regen may take up to 1 hour to complete. For static regen, the test will increase the engine speed to a high RPM for an extended period of time. For dynamic regen, the test will require the vehicle to be in motion for the duration of the regen. We'll be driving for an hour. Always perform the DPF manual regeneration procedure outside. Don't do it in the shop. The exhaust system, adjacent components, and exhaust outlet temperatures are very hot during this procedure, which increases the risk of personal injury and fire. Keep people and combustible materials away from the hot exhaust system. Good to know. And making sure, hey, did you read that stuff on the last page? Yes, I did. Turn ignition on, and in this case, this gives us a soot load calculation. So DPF has a soot load of 771%. 15 to 99 is partial, 10 to 120 is fully loaded, 121 to 199 is overloaded, and above 200% is fully clogged. And it won't let you regen, so in this case, we are way over. We are fully clogged, and it's going to say, no, sorry. Percentage of soot load is higher than the maximum limit to perform DPF regen. Prevent dangerous overheating. The diesel particulate filter, the DPF regen has been disabled. So there you go. Sometimes it's just not going to let you do it if it's gotten that bad. Now, usually if it's gotten that bad, the owner of the vehicle or the driver of the vehicle will have gotten numerous warnings about it, usually when it gets to that point. So if they wait that long or it gets to you and then it can't be regened, well, guess you need a new DPF, I guess. And then the last one I want to do is this Audi A5, 2024 A5, because there's something else I want to discuss related to this. So we'll go into the scanner and go into demo mode. And I do want to note that Volkswagen and Audi have put security on their vehicles. So they're called SFD tokens that you need to get in and do pretty much anything on here. So they lock it up a little bit differently, though. So if this was a Dodge, for example, you would have seen the security link stuff and it would have had to do all the things and would have had the thing on top. I can do a lot of things with these Volkswagens and Audis without doing any security. Like I can read codes. All right, getting codes. There's my codes. I can clear codes. Doesn't care if I do that. Read data. Perfectly fine. I can go in there and read my data. However, when I go into functional tests and I go into special functions, there it is, secured functional tests. So secure them at the functional test level. So what you need to do, if you have a snap-on scan tool, is you need to create a 4-digit profile access code, we call it, PAC, basically a 4-digit PIN. It can be any 4 numbers. You just have to make sure it's entered on your Snap-on account online. And then when it asks you for it, you need to make sure you put the right one in. So I'm just going to put in one that's not right. And you'll see, oh, I got four attempts. So I get 5 attempts total. So that was incorrect. So I'm going to do that one instead. But as long as it matches, it'll let you in. Now, in this case, I'm in sim mode, so it's also not going to do it, but it's still going to let me in. And then I'm going to go into my functions, and there we go. All sorts of different functions available for an Audi. Not all of them may apply to this particular car. Once again, I'm in demo mode, so reset adaptation values. Oxygen sensor, probably not maintenance related necessarily. Clutch valves, leaves in the maybe in the transmissions. Cooling oil valve, that might be related. Drain the fuel tank, that could be helpful at some point. Regen EGR cooler. Automatic test sequence 2. So lots of different things in there. Test of cylinder, individual mixture deviations. That might be useful for misfire. Timing chain elongation, reset after replacement. So after I do a timing chain on it, I need to reset it because it adapts for that. And you can also do a correction after not replacing the chain, but doing other work. A lot of nifty stuff in there, and it will leave the module unlocked for 90 minutes, and then you just need to unlock it again the next time you go in. And that is, if you have a Snap-on tool, that is included with your software. So no additional fees like others charge, and no weird hacker type workarounds that I've seen floating around out there too. You don't have to worry about messing around with any of that. It's just 4 digits, same 4 digits, can be whatever 4 digits you want. As long as it matches what's plugged into your profile on the tool, and the tool's registered, of course, to you, it'll just work. So Wi-Fi is necessary too. But other than that, current software, Wi-Fi, profile access code needed. And that is maintenance functions. And with that, that's our time here today. So make sure you tune in for new diagnostic content every week. We'll be premiering a new video every Wednesday at 7 p.m. UK time, so make sure to check it out here on our YouTube channel. Please make sure you also subscribe, thumbs up, and ring that little notification bell so you'll know anytime we post new content. With that, time for questions. Now, if you have any questions, once again, if you're watching this on the premiere, just leave it in the live chat and we'll do our best to answer those. Otherwise, leave a comment under the video and we'll get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've been giving you today. Hopefully we'll see you next week, and we'll see you on any of our other videos. Have a good week, have a good night, and take care.